Okay, let's get started. بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد وعلى آله وأصحابه أجمعين. My name is Dr. I'll be the chairperson for this session number 6, titled Communications.
And we are really sorry for this disturbance. We hope everybody is all right, and we welcome you into this romantic conference. We appreciate your attendance and ability to be able to join us online. We know it's hard time to grab your attention and your interest into this kind of events. We hope to be able to meet in person in next events, and we really looking toward fruitful session today. Our first speaker today is Dr. Eduardo. He has great experience in what he is doing in as a CEO of Calixto. His presentation will be, of course, of interest of everybody. So I leave the floor to him to discuss his presentation. Yes, Dr. Eduardo.
Okay, good morning, everyone. Now I try to share my screen. So let's waiting for the screen be shared. So my name is Dr. Eduardo Calixto. I have 20 years experience in reliability engineering, safety engineering, management, and now artificial intelligence. So I also member of EFNMES, the European Federation of Nation Management Society, and I work in two working group. These are the maintenance 4.0 and safety. And the presentation today is about artificial intelligence applied for maintenance 4.0. Just need to waiting for the screen goes on. I already set up here the button to share. Yeah, it seems that I have problems to share my screen. It's not coming.
Yes, can you share your screen, Dr. Eduardo? And
can you see my screen?
Unfortunately not. If you share the screen and then flip the page, so you when you see your screen, we will be able to see it, and you can carry on, please. Yeah.
Yeah, I already set up the button to share the screen, but it's not coming.
We're very sorry for that. Mr. Moderator, can we move the speech to the next speaker, and we will fix out the issue for Dr. Eduardo. Thank you so much.
Okay. Can you put me please on the main stage? Okay. Sorry for the inconvenience. It seems that we are having few difficulties. The next speaker is Dr. Ibrahim Alharthi. his presentation title, Remote Management for On-Site Work. Dr. Ibrahim, it's your turn to start your presentation, and you have 10 to 12 minutes for that. Please go ahead.
Yeah. Yes, welcome everybody, and we are really sorry to have this kind of technical difficulties. We know it's a bit challenging to grab the attention and to make sure everybody stay on the same page. So I'll try to make it mostly easygoing and without any jargon or details in what I'm going to discuss. The topic I'm going to present today is about how to use technology and what it enabled us to remote manage the work that is happening. As everybody knows, in operation maintenance, facility management work, our work is mainly linked to site activities, and our people, even through the pandemic time, were requested and were always present in working sites, giving those sites are airports, government facilities, mosques, and landscaping for some. So what we were able to manage through the pandemic is that we capitalized on the previous effort that we made before the pandemic. So when we had a plan before to rebuild our infrastructure and technology to make sure that they're following a scientific methodology, we assessed our situation and where we stand. So we use the way to understand where are our key difficulties and our key issues and how to start with them. So we identified that in our company, for example, we can look at information technology interlinked with departments through 4 or 5 main channels. It's mainly through the operational channel where all our work is happening, through the supply chain channel, finance channel, and the HR channel. We use the base layer development methodology proposed by Gartner to make sure that our base systems are configured and helping the main purpose they're supposed to do. By that, we look at them as a layer of system of record where we're making sure every activity and all the basic information are placed correctly in the system with correct data structure and are being used the way they should be used. Then we were able to look at some activities where we can have additional benefits of system through levels of system differentiation and systems of innovation.
Dr. Ibrahim, can I interrupt you? We
Yes.
are having interruption in your voice. It is interrupted.
Okay.
It is not.
So
Yes, now it is
better
better.
now.
Yes.
Okay.
Much better.
Okay. Can you see my screen as well? So I think this is happening
Yes.
when I flip into. You can see my screen as well.
Not the presentation.
You don't see my presentation.
No.
Okay. No worries. So I'll try to make it quite straightforward and simple, even if we don't have the visual aid of the presentation. So it will be all right. The most important thing is to make sure the message is delivered. So what I was saying, by looking at different elements of systems, we were able to identify the key elements where we need to put more efforts on. And that was before the pandemic. Luckily, when the pandemic came on, we were mature in several areas to immediately enable some of the elements for remote working and how people can log into our systems and see what they're doing. So this was not only a technology enabling feature, but it was a change in mindset. Having said that, in parallel with people used to be on ground, during the pandemic, we had to place additional measure for our people on site to make sure they follow the regulations and they follow the social distancing measure. They follow the required sanitization. They keep the premises that we are serving in accordance with the standards that are provided by the government authorities. So we use the systems in two areas. In the area of people who are working on the ground to make sure they're following what they need to do. And here is the key advantage for people who are in the head office, in the audit department, in the technical support, to have better visibility of what people are doing, and they use their intellectual to make sure they even do audit checks for people on site based on what they see on systems. We produced some improved checklists that are, we assume it's smart checklist. So we had teams and people, rather than doing physical visit, they just have calls with different levels of people on sites. They know each department or each section what they're supposed to do. They start to give them some questions to make sure, have you done these steps today? Have you done that yesterday? Have you done that the day before? Or you are expecting so and so materials. Are they delivered to you? Did you use them the proper way? Can you please tell me what is the procedure you are using to do so and so? So we were able to have a clearer picture in our executive management and central operation department of what is going on sites without going there, without being physically there due to travel restriction, quarantine, and so on. So this one we assumed is the key benefit that we gain from enabling and coupling the infrastructure, or the infrastructure that we did in information technology, the systems that we developed through a scientific way, having the system of record up and ready, having the background infrastructure ready to be enabled for remote accessing and so on, and the shift in mindset and additional measures we placed into audit and technical people to manage or to oversee what is happening in projects. We were able to assess also some areas that are related to productivity of people. We had an ongoing exercise, always looking at the cybersecurity and how the access management for people on site and people in head office using the system. We were able to manage the performance of some elements and so on. So overall, just to give a closing or a wrapping up to what is happening there, it is always important to carry on the mindset that work continuity is critical and important regardless of the difficulties you have. The other point is to establish, or when you invest early on in your infrastructure, in work methodologies and practices, the benefit of that will come when you need it in crisis times. And that's what happened with us. In some areas, we were mature enough to carry on, to continue our work without any difficulties. In some areas, of course, we are we are not different from anybody. We were affected in some areas, but alhamdulillah, in some areas we were able to continue smooth operation. The other element is also very important when looking from information technology perspective and other businesses, other areas as well. Being in the same page or following the trend of technology is always beneficial. So we had doubts before about moving some services to cloud-based and so on, but that proved to be wrong if you doubt being with the trend. Sometimes you have some hesitation about some elements, but where the technology giants, where the everybody is moving, where the trend is, where the research and development is there, follow that trend, because you will find better support, you will find better adaptation elements in there. And that's what happened with us when we have some of our services enabled to be on cloud and so on. We had less difficulties to publish that and use them through the pandemic. That's overall. I hope I kept you interested in it, and I'm ready to receive any question after the.
Yes, the question will be the end. And now we are going to have our next speaker, Mr. Rob Balok.
Thank you.
The title for this presentation is National. Mr. Go ahead and start.
Good morning, everybody. Can you see my slides?
Not yet.
You can't see my slides? Okay.
For me, I cannot see it.
Can you see that? Can you see that now? You can?
Yes.
Brilliant. Fantastic.
It is there.
Good morning, everybody, or good afternoon, depending on where you are in the world. Thank you for joining us today. My name's Rob Balok. I'm the Chief Sales Officer at Connexin, and I'd like to thank Amaintech for having me here today. I'm the Chief Sales Officer at Connexin. We're a smart city and national IoT operator, and I'm going to be talking about a UK perspective around delivering smart city applications. So in order to understand what we do, we need to understand, first of all, how rapid urbanisation is putting tremendous strain and pressure on public services, creating challenges for municipalities and for councils and for areas, challenges around how to provide cleaner, healthier living spaces for citizens, how to manage environmental sustainability, how to improve and create safer communities. These challenges aren't getting any easier. In fact, they're getting more difficult, if anything. And solving these challenges comes at a cost, at a time where resources are stretched further than ever before. And in the UK especially, we see councils and municipalities with legacy infrastructure, limited budgets, and they're struggling to keep pace with this rapid growth and this rapid urbanisation. And their traditional way of procuring services is in a very siloed manner, and it's not working. This siloed procurement, this siloed consumption of services, it's costly, it's inefficient, it doesn't deliver good value for citizens, it doesn't deliver a good citizen experience. And as cities grow, these challenges are becoming more complex, and cities across the world are looking for new ways to respond to these challenges and new ways to deliver a better quality experience for citizens. So at Connexin, we're delivering our smart city blueprint. We're building smart programmable cities in the future. And we're doing that by connecting things around us to our City OS operating system, using our next generation network infrastructure which has been designed specifically to deliver IoT and big data applications. Effectively, we are helping organizations to better understand their relationship between their people, their places, and their things. So the obvious question is, how are we doing this? Well, as I said, we're delivering programmable infrastructure. So we're delivering end-to-end solutions built from the ground up with intelligent connectivity, connecting to all the endpoints, delivered through our network of networks, whether that's LoRaWAN, fixed wireless access, Wi-Fi, and bringing all those data insights back into CityOS. In doing so, we're building infrastructure that citizens can understand their places and their things around them. So not only can our municipalities deliver better services, but citizens can make informed choices about where to go, where to stay, where to visit, where to work, and have a better quality of life. So how are we doing this in a bit more detail? So we're connecting a multitude of sensors from different siloed applications and bringing all those different data sets together. I'm yet to meet a council that doesn't have a lot of information, but having a lot of usable information is very different. So by taking those data sets, normalizing those data, we're able to make the ability to make intelligent decisions far easier. So how does CityOS do all this? Well, CityOS brings together all these disparate data sets, normalizes and standardizes the data that's coming into it. It then starts to become programmable. And through standard operating procedures, we can create rules and we can ensure that when certain criteria are met, automation kicks in, thus removing the need for human intervention, human decision, apart from the most intense applications. CityOS is really the core to bringing everything together and move away from that siloed way of looking at things. It's been really interesting, some of the engagements we've had where we hear city leaders talk to us about the difference it makes being able to visualize something versus seeing a series of data on a spreadsheet. It's a very subtle difference seeing a visualization versus a number. But as human beings, we're inherently drawn towards seeing things in pictures. And really key to all of this is the automation and how we can deliver these services through gaining these insights, and how we can help organizations to even look at commercializing some of these applications. So or driving outcomes. So by understanding traffic data, understanding how busy a place is, football data, and having accurate information around events, city planning and weather, and combine all these things together, we can start moving towards models where we can attract people to cities during quiet times, or distract people from going to places when it may be busier. Car parking being a great example. If we're trying to regenerate the high street, reducing parking tariffs on days where it's quiet will drive some people to enter the city versus the days when they may not have done. So some examples of some of the work that we've been doing. If you think about the journey that we've been on over the last 3 years, we're one of the leading providers in the UK. We've got some projects in Europe and always interested in interesting projects. Newcastle is a council in the north of England. They won the Smart City of the Year award for the UK in 2019. A fantastically forward-thinking council. We worked with them in 2018 to deliver the UK smartest street, and that was really taking a people-first approach. This is a perfect example of a council that thinks about outcomes rather than technology. This is their council plan on the page around the infrastructure that makes Newcastle a great place. We delivered all sorts of services for them as part of this engagement, smart parking, waste, air quality, and a few other things. And they've gone on to do great things since then. Another really interesting one, a couple of examples, is Hull City Council, again in the north of England. Hull has taken a strategic approach to the adoption of technology, top-down leadership from the head of the council all the way down through all their different departments. They've gone platform first. They aren't looking initially weren't looking at IoT. It was all about bringing together existing data sets. To comment on Dr. Ibrahim in the last session, this council has had particular advantage in the UK during the pandemic with COVID, because they'd already made the investment in a solution which will bring together existing data sets and new. So they've been able to import different data sets to help with the response to COVID. Making a wise investment during steady times obviously has set them up for success in more challenging times. And then finally, I'll just touch on our other engagement with the private sector. So in the UK, we have a number of organisations that deliver services to councils. We call them PFI contracts. So Amy has as part of the Ferrovial group, we're providing services to digitise the way they provide highways management. They've got a 25-year, £2 billion contract with Sheffield. So we've helped them digitise the way that they empty bins, the way that they detect flooding, the way that they clean their gullies, the way that they monitor the moisture and when trees need to be watered. We've digitised all these services and delivered huge savings in terms of efficiencies and carbon reduction. And then finally, I'll just touch on another sector where we've been working quite a lot. So the water utilities in the UK are not part of the municipalities. So we've been working with a number of the water companies in the UK, projects around smart water metering, projects around smart water networks. So we're connecting things to their networks. So we're delivering sensors, we're delivering enabling water meters, all really to drive the reduction in leakage and consumption. Leakage and consumption is a huge cost for the utilities. Utilities in the UK consume about 4% of all UK electricity. If you think about the energy which goes into pumping clean water around the system, being able to reduce that by 15 to 20% has got a huge impact on the overall carbon consumption that the utilities are consuming. So I'll summarise, we're doing some really interesting things, working across multiple sectors. We're working with councils, with private sector, with utilities and manufacturing and buildings. If you'd like to get in touch and want to know more, please check out the website or get in touch on LinkedIn. I'd like to hand back over now and thank you for your time.
Entitled The Artificial Intelligence for Maintenance 4.0. Eduardo, please go ahead and start.
Hello, can you hear me? See my slides? I just would like to have a feedback.
Yes, it's very clear. Go ahead, please.
Okay. So I start my presentation. I already present myself. So in my presentation, I have some glossary. You are going to see all this concept along the presentation. So basically, artificial intelligence is a technology that enables machines to take a decision based on that data collected and assess it. And in a field of maintenance, when it says maintenance 4.0 means that some technology, that means algorithms based on statistical mathematics model, are able to transform information, data in information, and enable such information for maintenance engineers, leaders take faster decision. In the field of artificial intelligence, we have what we call machine learning, and machine learning are the methods that transform such information in such data and information in three different categories, such as cluster, organizing such data, or classifying or prediction. In case of machine learning, we have different methods. Unsupervised machine learning. The unsupervised machine learning is based on clustering and a group of data, organizing data. Supervised machine learning, we have supervised machine learning classification that classify the data in categories, and supervised machine learning regression that's make prediction about some continuous dependent variable, for example, remain useful life. So I already make my brief introduction about myself. I just jumped that. Just an information, you can get all basic information concerning ECC and myself on ECC website. And the agenda for today is start with the brief introduction, then go through artificial intelligence concept, then speaking about machine learning concept, and then I go deep in more details about the K-means methodology. That's one of the unsupervised machine learning. And in the end, I will present a case study. Okay, as I mentioned before, artificial intelligence are technology applied to enable machines take their own decision based on data collection, or even transform data into information for maintenance engineer, maintenance leaders, and technicians. So what we are talking about today is one model, machine learning, and specifically unsupervised machine learning. What is general concept that we have in machine learning? So since we are collecting data, this data can come from a sensor. For example, if we are measuring vibration in a pump, in a bearing pump, or if we measure temperature, or if we measure humidity, whatever parameter that we measure, we have a data set. So we can have a 100 measurement, or even that is a very important concept. That's most of discussion about machine learning concerning about taking into account only data that comes from sensor, but in fact you can also get the data that you've got from your predictive maintenance and apply in some machine learning model. So the general concept of machine learning, since you have this data set, no matter it comes from a sensor or your predictive maintenance, for example, non-destructive test, ultrasound that measure thickness of a corrosion, you have this data, you have 100 data, then you need to share this data set. So what is split this data set in training data and test data. So usually you split 70% and 30%. Then the next step, you choose a model, depends what you want to do, if you want to do classification, if you want to do regression. So based on the model that you choose, you use this 70% of the data to train this model. And then you see the results. If it's classification, you see the accuracy. If it is a regression, you see the precision of the data. And in the end, you can verify by applying the other 30% of your data. And then you test your model again and see if it fits good. If it fits good, you come out with a new data set, more than 100 data, and then you use the same model and validate, and then you continue using that. The other type of machine learning that we have is the unsupervised machine learning. This is a different approach. You use the whole data set here, let's say the 100% measurement or two parameters that you have, that's define your data, and then you organize your data. That's the cluster, means organize your data based on the parameter that you choose. For example, expect time to failure and cost to failure. Two dimensions that we said is two variables that we want to organize our data. And then you do the verification, and then the result is good, you need use new data sets, validation model, and apply your model. So let's take a look on what we call machine learning classification. So we have different types of machine learning classification. And then, of course, the good advice is to, whenever you have some data, apply all of them and see the difference, the result that you've got there. And always apply the model that's better fit on your data. So here is an example of classification data. I want to classify my data based on remaining useful life. So here, the remaining useful life is from 0 to 12 months, and RMS, there's a rotational velocity that's range from 2.5 to 7. So we can see that's the model here classifying in blue the ones that's considered critical, that are this group of data that are in here. So these data are classified as critical because they have a high rotational velocity, rotational vibration, and low remaining useful life. And then we have a middle here that is in orange, and the less critical in red here that have a high remain useful life and lower vibration. So they classify the data. We can have different classification. Now, similar, we have this machine learning regression models. We also have different methodologies to perform regression and predict some variable that we intend to predict. So since from the simple linear regression to the more complex models such as neural network, we have different models. And again, the good advice is always use, check it with different models, the result that you've got, and use the model that brings lower error for your data. So here, example of regression, I just use some data here, and then I apply the sum of these methods, and then they give me this straight line to predict the temperature or the remain useful life based on the temperature that I've got. And that's the main objectives of this supervised machine learning regression. And when you're talking about unsupervised machine learning regression, we have also different methodologies, and then we need to apply these methodologies to check how our data will be organized. And then, of course, we have a more simple method such as k-means clustering, the one that we presented here, and more complex method that's neural networks have organized method. So we can apply all of them, check, and of course, if we see that one model fits good to our data, we'll assume that the model is enough. So here an example of unsupervised machine learning model, and then we are grouping the data. That's the case that I will present later on. That we have different similar bearings from pumps, and then we have remain useful life from 0 to 14 months here, and we have degradation progression signature. That's a percentage of degradation for this bearing, consider the vibration. Then we can see here, and on the left and up side, the let's say the group of bearing from pumps that have higher remain useful life and lower degradation. So that's one is not a priority. After that, we have this group here in dark blue. That is a middle remain useful life and middle degradation. Here, those are the priority. The model a group this data here in only one group that have between 4 and 0 remain useful life and have middle to high degradation. And then that's the objective when you try to organize our maintenance plan. And that is the concept of optimization. So basically, when you want to optimize our system, what you're looking for is to maximize our operation availability and minimize our life cycle costs. But of course, each equipment component have restriction. Then let's consider a system that have different equipment. Different equipment will fail in different times. And then, of course, if I sign to order spare parts and shut down this equipment different times, I can cause many shutdowns in my system. So the whole idea is to define the optimal time that I can perform preventive maintenance in a group of equipment and reduce the number of shutdowns. And that, of course, will go further and further. We need always to update the further intervention for a group of equipment, and based on it, we are able to maximize our operation availability and minimize our life cycle costs. So, and that's why I presented here the k-means model, unsupervised machine learning. That is very simple concept that you can see in this picture. So basically, we have to define our variables, or what we said here in the graphic dimension. So I consider here that I want to organize my data considering preventive maintenance costs and equipment criticality. And then I need to define the K, the number of clusters. Here I define 3, blue, green, and yellow. And then based in this cluster, all these points that each one represent one equipment with a specific preventive maintenance cost and criticality will be organized in different groups. And based on these groups, I can take decision. So which are the steps of k-means algorithm? So the first one to define the value of k, that's here, is 3. The second one is to define aleatory centroid point to start the clustering. So here we can see the picture. That's not the best centroid. Centroid is a point is centralized this group of data, this group of data, and this group of data. I just get aleatory 3 centroids for each cluster. Then the next step is to calculate the minimum distance between the closest point to the centroid. So what does it mean? So now that I have my centroids defined, I start to get one specific point, let's say this point here. Then I calculate the distance from this centroid to this centroid and the other centroid. The one that have the minimum distance, that means this centroid, will define that this point is belongs to this cluster. And then you do that for all the points. Then the next step is to update the centroid points based on average position of each group. So since I have already defined now the cluster, I can update it, the centroid here. You can see that the blue point here is not centralized concerning this group of data. So I can define my centroid here and get a new centroid in this point, similar to the other clusters. And then the final step is to define new centroid and run the process again to define a minimum distance between the centroid and point and inside each cluster. So I will define how many times I will run again this process to get a better cluster definition. How can I define the distance between the points? I have 3 methods to define the distance between the points: the Euclidean distance, Manhattan distance, Minkowski distance. So Minkowski distance is a general application of these 2 cases. If k equal to 1, I have the Manhattan distance. If k equal to 2, I will get the Euclid distance, some similar. And then based on it, how it works in a real case. And then now I will present the case study. And the case study, as I mentioned, we have here 27 pumps. And then these 27 pumps, I get this velocity, rotational velocity here for each one of them. And then I want to group and to define which are the pump that have the highest degradation and have the lowest remaining useful life. A group then to take the decision to perform the first preventive maintenance intervention. And then, of course, I put in here pumps and consider the bearing case, but I can put whatever group of equipment. Usually in maintenance teams, we have different departments for rotating equipment, for electrical equipment, electronic equipment. That's why I organize one example to make simple here, just pumps and consider bearing. Then what I use to apply this model is basically the, let's say, the MATLAB. So the MATLAB is a software that we can apply different machine learning methodology. So this we need to, in MATLAB, to implement here some code. So here means these 4 lines means that I will come out with a file that reads my Excel file. Then I will normalize this data. Then I will format this data. And then I give the comments for the k-means. The k-means we have 3 clusters and replicate 5 times. And then I will plot the model. So basically, what I'm going to do now is just to shift for to demonstrate to you the screen that if you can see how does it work. So basically, in the MATLAB, what we have, we need to import some Excel sheets. So we already have the command here. I import the Excel sheet here, the data. So it's a simple Excel sheet. I collect my data. Since I import, I give the command to read, and I put here the name of the templates, and then they read the template. All the information I have in Excel comes here. Now, what I'm going to do is to basically to format the data, and in the end, what I'm going to do is simply to define the command that I mentioned, that is a k-mean command. And then, based on it, yes, sorry.
Dr. Eduardo, please, your time is over. Please, if you can go to conclusion and wrap up this presentation.
Okay, so just demonstrated here the real case. Now we have these 3 clusters here in blue, and here in the middle in gray, and here in the middle the other one. So I just go to conclusions, my presentation here. just the bibliography about artificial intelligence concerning machine learning. I have my new books you can find in Amazon, and also I have an online training concerning the machine learning, all these steps. So just a very important conclusion is that we need to have in mind that machine learning we can use in our data that we have in the field, put in an Excel sheet and use the MATLAB, a model such MATLAB to predict and use different machine learning methods. The other point is to compare different methods and get the one that is better fit on your data, and real understand the machine learning methods, because we can see in many cases, application and organization that's just not explain which are the model that we are using. It's a black box, or in many cases they are not aware and not explain that. So it's very important maintenance professional have the clear picture about how to use that and what's the results they coming from that. Okay, so thanks for for your attention for the time, and I'm open to answer a question if there is someone.
Okay, I'd like to thank our speakers for their wonderful presentations. Now the door for discussion is open. I'm supposed to receive the questions of the participants. Okay, I'm still waiting to receive the questions of participant at the presenter chat. It's not the chat. Okay, so far there are no questions from the audience. Okay, if there is no questions, then I would like to thank everyone. I do have one question for Dr. Eduardo before we end up this session. It's about your prediction process. Is it based on math calculation, or depends on the equipment history?
Depends of both, because as I demonstrated in my presentation, we have an Excel sheet. In this Excel sheet, we collect all the data that come from sensor or come from a predictive maintenance, as I mentioned, for example, corrosion thickness. That is one step. Also, as my colleague Rob presents, we can have smart sensors that collect millions of data, and that's come automatically for a model. So that's the first step, data collection. Then the data go to some analytic basis. And what I'm showing here is that we use a specific machine learning model to organize the data. This K-means methodology, they use this algorithm and use the mathematics that is behind that is first the Euclidean distance that calculates the distance between the point to each centroid, and also how to define all the steps from the algorithm. So it's basically an algorithm that follows steps and have some mathematics backgrounds. There are different methods that are based on statistics, consider standard deviation, but depends on the methods, they have different mathematics behind.
Okay, one more question about the equipment history. How much time you have to accumulate? 3 years, less or more?
No, that's don't need to define. That's the concept that we have in machine learning, that we need to have a lot of data. It's not, definitely it's not, because depends what you want to do actually. But in fact, if you have data for, let's say 100 data, is a good data set for starting to make some prediction, or even less. You will get this answer when you apply your model and see how accurate your model, you know, that is the big answer. So you need to, if you have a small number of data, I suggest apply some model, check the accuracy and the precision. If it's good, that means your data fits good, and you, of course, as long as you get more data, you update your methods.
Okay. My second question for Dr. Ibrahim. Dr. Ibrahim, can you hear me?
Yes, can you hear me?
Dr. Ibrahim.
Yeah, most welcome.
Okay. As per your presentation, remote management for on-site work, are you having future plans to extend this experience as part of your improved strategy?
Many thanks. Sorry, it looks like I have a difficulty in getting your question, so I didn't hear it. If you can write the question
Okay,
in
can
the
you
discussion forum or
can you hear me now?
yeah, I couldn't
Can you hear me now or still? How about now? Can you hear me? Let me write it down for you.
Let me rephrase.
Okay, Dr. Ibrahim, can you hear me now?
Okay. Yes, can you repeat the question again?
Okay, you can hear me now, Dr. Ibrahim? Hello? Hear me now, Dr. Ibrahim?
Yes.
Okay, my question about, as per the title of your presentation, remote management for on-site work. As per the title of your presentation, remote management for on-site work. Now you have experience using online or remote to manage site. Do you have any future plans to improve your strategy using this experience you gained during COVID-19 working on remote?
The strategy, the good thing that we came out after this pandemic, that we had a proof of concept for our executive management, that managing people and sites does not necessarily always require physical visits, and we can use the smarter and more detailed investigations. And some of the stuff that we can manage remotely or we can monitor remotely, to be monitored remotely, to increase the efficiency and effectiveness of how we collect and how we manage our remote sites. Yeah, we already had the proof of concept for that, and we communicated that with our executive management, and hopefully it will be implemented down the line. Thank you.
Okay, thank you, Dr. Ibrahim. Okay, at the end of this session, I would like to thank everybody who did participate in this session. And I would like to remind you that there is a short break. And after the break, we can all continue as per the agenda outlined in the timeline. Thank you all for participation, and hope to see you in another sessions. Thank you all.
You're welcome.
Thank you.
Bye-bye.
Bye.